confusion matrix works. If you see this diagonal, it's everything in this place. This means that everything that you label was found accordingly. In this case, I trained 5 images and I used the other 5 images to check if my application was finding correctly. You can also find something like a very small dot in this confusion matrix. This means that you label something as mozzarella in this case, but it was actually found as pepperoni, and that's not good. So this wasn't the case for my application, but if you see using the classification tool, something like this is a signal that something is wrong. Probably you need more images, or maybe probably you have to change some parameters of your deep learning tool to optimize your application. In this case here, looks very good. So I'm confident that I can do easily this classification. What is fungi, what's mozzarella, what's pepperoni. Now I found the pizza, it is mozzarella. So how can we check if the mozzarella is good or not? In this case, I was using the green classify tool because I've just collected 140 images in this case. I label 50% of them. Sorry, I label all of them, but I trained just 50% of them. So I am building my neural network, creating my tool based on 50% of the images, and I'm using the other 50% of the images to check if I can find correctly what's good and what's bad. And this was working really good. The F-score was also 100%. So these two first classification tools were not very challenging. It was quite simple to set with the classification tool. When it comes to the pepperoni, it was a little bit more challenging, because I had, first of all, to find the correct location of the all pepperonis, because the pizzas are rotating. I don't have always this orientation of the pepperoni. And I was using the blue locate tool with the node model to find all those pepperonis. With the node model, I find every single pepperoni and I connect all of them. And then I know exactly what is the angle of the pizza. After that, I am chaining, I am connecting another deep learning tool. So this is also a very good advantage of inside VD, that you can connect 2 different deep learning tools, one after the other. I am using the coordinates of the locate with nodes, and now I'm using the layout model to check if every single pepperoni is in its right place. And as you can see the results, I got 100%, and I was training 45 images, and I was checking the results on 44 images. So I was basically training, again, 50% of the image set and checking the results with the other 50%. So in this way, I can find all the pepperonis and I can specify if every single pepperoni is in the correct place. And I can also do a second check. I have another tool in parallel with my locate layout, and another tool getting the information, the X, Y, and angle from the locate tool. And now I'm using an analyze supervised. So as you remember, I was labeling these mushrooms, or I was also labeling some tomatoes, and anything which looks strange in my pepperoni, I was using exactly this tool. And with this tool, you have to highlight where are all the possible anomalies. You know how it looks like, and you teach to the system how it should expect, how it should find all these anomalies. In this case, I've trained 42 images, and I was checking the results in the left images. And you can see that I have a perfect segregation. So I have this big gap between the green and the red. So this means that everything that I label as good was found as good. Everything that I label as bad was found as bad. You can see one example below. The left image, you can see some tomatoes and also one mushroom, which is kind of hard to see. And in the right, you see the graphics. So VD is really finding any anomaly on that. And why deep learning for that? If you would try to set some traditional vision tools to do this kind of inspection, you have no chance. So with the traditional vision tools, you could be maybe able to find in a couple of images, but due to the large amount of variation and change, you cannot predict and you cannot put together a bunch of images with its parameters that is going to detect all kinds of anomalies that you might have in your production line. Therefore, here, we really need a deep learning tool, a powerful deep learning tool to do this check. So here again, my confidence level is very high because I was able with this tool chaining, do all kinds of different detections that the pepperoni pizza was required. When it came to the fungi pizza, I have an important tip for you here. Lots of mushrooms on top. Imagine how much time you would have to invest if you would go precisely drawing where all the mushrooms are. I did not have to do that on 102 images. So what I did, I'm going to share with you. We have labeled. I was actually forcing the system to create the neural network based on 10 images. After the tool has been trained, the system will process all the 102 images using the new tool that I have created. So I label just 10 images, I process all the images, and the system will find all the potential candidates for mushroom in all the images, not in the 10 anymore, in the 102. The system will mark almost all mushrooms from the 102 images for you. So that's what the system did for me. Now you go through image by image and you check if V did a good job by finding the mushrooms. If the markings are good, you accept the views. By accepting the view, it's a kind of handshake. You say, hey, VD, I agree with the markings. So if the markings are perfect, you agree. If something is missing, you can use the erase and you can fix. And if something is even missing that, you can also add some new mushrooms. But you see that you don't have to go through all the images and do the labelings in details. You can use the system to do a first training for you and use the results as an input for you, and then you are just going to fix what the system suggested. For the markings that you don't agree, you can erase and the incorrect markings and fix it. After you revise all the images, you train not 100% anymore, but now 50%. Why that? Because you're going to train now 51 images, and the other 51 images will be used for checking if your tool is working reliably. And VD trains fast, does not require many images for achieving good results. With just 3 trainings, we could optimize this tool. This is also one advantage of VD compared to open source as well, where you need much more images to get good results, and the trainings takes much longer than VD. Cognex has VD, and VD doesn't use convolutional neural networks, which are more complex, require more expensive hardware, and it takes much more time for training and also for processing. With VD, you can, for example, in this case, I was doing the training in 4 minutes. I did some changes. I trained again 4 minutes. I was doing just some fine tuning, and I trained again, and I had a very good result. You can see that I achieved here 90%. So for this kind of segmentation, it's really good. So this means that from all the mushrooms that I have drawn, the system is able to find 90% of every single pixel. This is a very good result. And this also gives me a very high confidence level that this tool is going to work reliably and consistently. And this is the result. You can see that we can find there are some very small pieces of mushrooms that we still miss, but that's not a problem. We can meet the spec by finding it correctly. And this image was not trained. This is one image which shows the results from the inside video. So now let's move to validating the application. You have already optimized, so you have a very high confidence level that this is going to work well, but you have now to test in real life. You have to validate that. And deep learning can only be validated statistically. That's very important. You have to collect a good amount of images and do the validations. What we did here, we have separated 5,000 pizzas, good and bad ones, and we knew beforehand what is the flavor and what if those pizzas are good and bad. It's important. So here, 5,000, it can sound a little bit too much, but you don't have to do the validation with 5,000 images. Of course, that the more images you have, the higher is going to be your confidence level based on the results that you have. But if you don't have 5,000 parts to do the validation, it's also not a problem. And we have used the new D900 5-megapixel color camera. So this was the result that we've got out of that. So now I will go through step by step to explain you how to read those results. So let's magnify a little bit this overlapping, because that's very important. You see the left side, all the green ones. These ones means, so these 4,092 images or pixels means that everything that you label as good was found as good. In the right side, you see the red ones. These 883 images we labeled as bad, and we also found those ones as bad. So far, so good. But now we have some intermediate results here. And it's good to have intermediate results. You can see the intermediate results with these dotted line, green and red lines. You have here the lower threshold and the upper threshold. Everything which falls in between these two thresholds is considered intermediate result. And it's good to have that because you can take a different action if it's falling that. Some customers don't care about intermediate results. You can just overlap the lower and the upper threshold. And if you do that, the system will be binary, good or bad, and that's it. But you can take a different action if it's falling in between that. And we also have here, this is the first problem that we found, is that we had 11 pizzas which were labeled as good, and it was found as bad. So it's not a big problem. The good news is that everything that we label bad, so this is the truth, we found 0 as good. So we don't have false positives. You can see here that the false negative is below 1, and I'm even considering the intermediate result as well. So remember that I have the target of 1% of false negatives. So here it's okay, I am below that. And we also have we are also below 0.5% of false positives. And I am considering also these 3 intermediate results. So we are really meeting both of specs here. And this makes my confidence level be very high about this application. We have 5,000 images. Out of that, we are below 1% of false negatives, and we are below 0.5% of false positives. This is how we validate a deep learning application. Now let's move to the reference and summary. Take advantage of Cognex Deep Learning Deployment Guide. So everything that I spoke here about this pizza application, you can find in cognex.com. You just download the VD Deep Learning Deployment Guide. And as I said since the beginning, this is about pizza, but think about your application. Think about how you can go through all these steps on your application as well. Let's go for the summary. Return of investment or payback, encourage customers to invest in deep learning. So we can convince our customers that it's worthwhile to invest in deep learning, and you can convince your managers and directors that it makes sense to invest in this technology because it can solve problems that we could not solve before. There are lots of benefits about automatic visual inspection. I mentioned that as well. The first project cannot be too hard, neither too easy. You must find a sweet spot. So don't go for the hardest one at the beginning. You are going to learn for the first project. So find something which is hard enough that standard systems cannot solve, but also not too complex that you're not going to invest so much time for the first one. For the second one, you have already built your experience. You can target more challenging projects. The proof of concept is very important as a first step. However, we must move to the production line as soon as possible. Remember that I was showing 2 images with different lighting, for example. This happens a lot, so make sure that you have final setup or as close as possible to the final setup so that you don't have to invest so much time in optimizing your application when you are in the final production. Consistency in labeling is extremely important. So if you start labeling with one approach, finish with that approach, don't use 2 different approaches because this might confuse the system. And this previous step is not just about defect detection, it's also about classification, about location. So if, for example, for location, if the size If your feature size has one size, don't change that afterwards. If your classification, if you classify parts as good, and then you have some good parts and some bad parts, you classify all of them as good, all of them are bad, and then comes someone else and is changing some good parts to the bad part, this can also mix and confuse the system. Deep learning is a different animal. The reliability and robustness is measured based on the statistics. We need a set of images and or running the line in order to validate the application. So we're going to do a pre-validation using the software, and then we do the validation in the production line. Consult the deep learning deployment guide. That's very important. Everything that I spoke here, it's even with more details in the deployment guide. And now I'm going to show you one example, the final work that I've got out of this application. You can see that this is the web HMI that I have created. It's very flexible. You can choose where you place icons, where you have your image. You can create drop-down lists. You can create checkboxes. You can create icons and logics to show what you did. So in this case, I'm doing all the 3 inspections. You see that I have a classification tool finding which pizza is coming in the production line. As soon as I find which pizza is coming, I do a separate check to see if this pizza is good and bad. So we are checking the pepperoni, the mozzarella, and the fungi pizza as well. We have a film strip that it shows the last 3 results. And the application was running really good. So the customer was really impressed about that. So questions, let me see if you have already asked some interesting questions here. Just give me a little bit time. So the first question is, what was the speed of the application? So in this case, the HMI was running with interval time of 2 seconds, but the application was roughly inspecting everything with 600 milliseconds. So with the D900, of course, this is a kind of complex application. There are some processing power limitations, and here we are inspecting with 600 milliseconds. If we have to be faster, we can do some optimization, but if it's still, we have to go even faster, this is probably a signal that we have to move to a PC-based system, but we also have this option. I see a lot of questions about which camera needed. So the cost of the license, it starts in 2,000 euro per year and goes up to 3.5 thousand per year. But we have starter kits, which give you even more attractive price, and you need just one development license to develop applications for all the cameras. One development license, you can start developing applications for all your cameras. And if you have a partner, you don't need a development license because the partner will do that for you. So next question. Is the neural net saved in the camera? What computer is running on it? Yes, it is saved in the camera. We have two high-end inference engines which enable this camera to run deep learning tools. So we need a lot of processing capability to run that. It's not just about software, it's also about hardware. Therefore, we have designed the D900 to be able to run deep learning tools. So we have two inference engines plus 4 ARM cores in this smart camera. It's a quite powerful smart camera. Next question. Software skills necessary for programming it. We offer trainings for our customers, and if you attend to one of our trainings, it's going to be 2 days training. We system, or do we need specialized technicians? So with the HMI, as I showed you, it's very flexible. The region of interest, you could also have some drop-down list, some checkboxes. But if you want to retrain the neural network, you need someone. So you have to attend to this 2 days training to do these changes. For example, if you have a new pizza, a new product, the operator cannot just add the pizza by himself. You have to go offline, reprogram the camera, add more images, train again, and then the system will be able to detect the new pizza.